Hello, algebra students. Mr. Lawrence here, and here's the problem we started in class today. I wanted you to review how to do it, remember? So let's read it really quick. A chemist needs 200 milliliters of a 40% acid solution. He has two bottles of acid, one that is 20% acid and one that is 55% acid. How many milliliters should he mix together from each bottle to create the desired mixture? And remember, we were setting up a chart, right? We cared about the first bottle, right? And I think we called it bottle 1. Okay, looks like there's an extra little thing in there. Sorry about that. Okay, and then bottle 2. And then together we had our mixture, right? Okay, and so starting to make a chart like this. And then the story told us about the number of milliliters. And some of you had a hard time figuring that out. Well, remember, that's the question. How many milliliters do I need? So that's an unknown. That's what makes it so simple, is that we don't know. We can use variables. All right, and then it talked about the percentage of acid, right? The percentage of acid. And then we talked about the milliliters of acid. Okay. And in the different classes, we got to different places, but we know that we don't know how many milliliters to use from bottle 1. We don't know how many milliliters to use from bottle 2. We do know that the mixture has to have 200 total milliliters. And so, in second period, Julia Glogi said, hey, x plus y equals 200. Right. We don't have that much information filled on our chart, but we already have an equation. And then they said the percentage of acid, I think, was what, 20 hundredths? Because remember, we have to divide by 100. And then for bottle 2, it's 55 hundredths. And for the mixture, it's supposed to be 40 hundredths. And it's totally cool to put 2 tenths there and 4 tenths there. Okay. Well, then, to get the second equation, first thing I did was multiply the 20 hundredths times the x, and the 55 hundredths times the y, and the 40 hundredths times the 200. And I think when we did that, we ended up with 80. Okay? I'm going to use the 80, not the other form. So now I have my second equation. It's 0.20x, 20 hundredths x, plus 55 hundredths y, and that needs to equal 80. All right. Now, I recommend doing this by substitution, so I'm going to solve this top equation. I think for x. Okay? Angela Demchuk mentioned that it might produce prettier numbers for us when we go to substitute in, and I totally agree. Okay, so we're going to need 20 hundredths times x. Well, x is the same as 200 minus y. And then we need to add 55 hundredths y to it. And that needs to equal 80. So now I do my multiplication. Let's see, 10%, I need 20% of 200. 10% is 20, so that should be 40. And that'll be minus 20 hundredths y plus 55 hundredths y, and that will equal 80. I'm going to combine like terms, and that will end up with 40 plus 35 hundredths y, and that will equal 80. And then I'm going to subtract 40 from both sides. And let's see, I'm going to get 35 hundredths y equals 40, and divide by 35 hundredths, divide by 35 hundredths. And so then y is going to equal, hold on a second, I'm going to, in the interest of time, do this using a calculator. So we have 40 divided by 35 hundredths, and I'm going to end up with 114. And it's going to be 2/7, or you can say 114, approximately 114, and 29 hundredths milliliters. I wouldn't round to the nearest tenth on this. I would go to the hundredths. Okay? And then, now to figure out the milliliters of the other bottle, I'll do X plus 114 and 29 hundredths equals 200. Okay, so if I subtract 114 and 29 hundredths from both sides, what's that going to be, 86? I'm thinking I'm going to get 85 and 71 hundredths milliliters of the 20% bottle. That should be right. I'll just double check myself so I don't have some silly mistake. Yeah, that's right. Okay, so there it is. There's your one problem. All right, Mr. Laurence signing off. Have a good night, everybody.